8.3 is confidence intervals for one population when the population standard deviation is unknown. So this is really not anything different as far as the work that you're doing, your setup. The only thing that is different is you won't see the word population standard deviation. You'll see the word sample standard deviation or little s. Now, if we were going more in depth with this section, you would be looking at two different bells. Your bells would be very similar. The area underneath them would still equal 1. Your curve steepness would be different. And instead of it calling it z-scores, you will be hearing the word t-scores. But to find either one is the same formula, okay? So there's not much of a difference. It's just that you're going to now utilize the big chart, the chart that is on front and back, okay? Or for y'all, 2 pages. I'm just going to do 2 examples to kind of, because it's the same stuff as 8.1, 8.2. It's just that we got to utilize the bigger chart instead of the little box, okay? So let's look at example 1, family fun. It says, taking the family to an amusement park has become increasingly costly, according to the industry publication Amusement Business, which provides figures on the cost for a family of 4 to spend the day at one of America's amusement parks. A random sample of 25 families of 4 that attended amusement parks yielded the following costs, rounded to the nearest dollar. Okay, so you have that information in the chart. It says obtain and interpret a 95% confidence interval for the mean cost of a family of 4 to spend the day at an American amusement park. Note, very important information. X bar, that's your sample mean. It's already done for you. Is $193.32. And I need you to see that says S equals $26.73. So with you seeing that little s, that means the sample standard deviation. Sample standard deviation, okay? That's what that little s means, sample standard deviation. So, here we go with our, well, first, before we go plugging in, let's look at the chart. Let's pull that chart back up. Okay, on our chart, I've kind of zoomed in on mine, but yours is all the way to 49 on the first page, and then on the second page, it starts at 50 to 2,000. So, if you notice your heading, that's what I want to focus in on, your heading. You have a DF column as well as a T-score column, so to speak, because now we're dealing with a T-curve instead of a Z-score with the bell curve. So the DF column represents degrees of freedom, okay? Degrees of freedom. Now, when you're dealing with the population unknown, meaning you don't know what the population standard deviation is, and you might want to label that for this chart. Let's put population standard deviation And that's the terminology they use, is unknown. This is when you use this chart, okay? When you don't know that population standard deviation. I'm not going to go into the degrees of freedom, but that deals with the steepness of your curve, okay? But for you using this chart, you would need to know specifically what row to be on, as well as what percent to get the right T-score, okay? So your degrees of freedom, it has a little formula, which is n minus 1. So whatever your sample size is, you always subtract 1 from it. So if we're dealing with 25, then we must be on row 24. You're always going to go to the row one number less than your sample size, okay? So that's your degrees of freedom. Now, we're not graphing any of these bells, so that's why I'm not going into the detail of the curve look, okay? Now, I do want to label your percentages. They will follow the same labeling as the little box on the back page, okay? It has the exact same little labeling, meaning that this first column, let me erase. This first column is going to represent 80%. The second column, it will represent 90%. Third column is 95. The next one is 98. And the last one will be 99. So it has the same order as your percents, okay? So this time, not only do you need to be mindful of the percent that lets you know what column you're on, but you need to make sure you have the right DF, which would mean what row we're on, okay? So keeping that in mind, going back to our example, we're going to plug into our formula. Now the formula might look a little different, and I'm going to show you why. Instead of having a Z, it has a T. And instead of having that baby sigma sign, you have a lowercase s. Because this is dealing with the T curve, and you need the sample standard deviation. But it's the same type of stuff, okay? So we're going to plug in our mean is $193.32 plus or minus. Now it tells us we're going to do, let me do some highlighting, a 95% confidence, and we have a sample of 25 families. So your DF would be 25 minus 1, which is 24. So we got to be on row 24. So we're looking at 95%, making sure it does say 95%, which means the third number on row 24, which would be here, okay? That's your Z-score, 2.064. .064. And we're going to multiply that by the sample standard deviation of 26.73 divided by the square root of 25. You see, it's the same plug-in. So we're going to divide 26.73 divided by 5. That would give us 5.346 that you're going to multiply by 2.064 to get your margin of error. And that would give us a margin of error of 11.034144 that we're going to add and subtract from 193.32. And I'm going to write this interval here. So we're going to subtract that from 193.32 and 2 decimals because this is money. So that would give $182.29. There's a 5 behind that 8, so that rounds to 29. And we're going to take 193.32 and we're going to add 11.034144. And that would give us $204.35 as our interval. That's our confidence interval. Now it did say to interpret, and that's where you would do the sentence, the statement. And that statement is worded, we can be, that's how you always start it off, 95% confident that the mean cost and you don't have to put all of that extra, that the mean cost is somewhere between $182.29 and $204.35. That would be our interpretation. Let's look at the second example. It's on bottlenose dolphins. And it says the web page of bottlenose dolphin produced by the National Geographic Society provides information about the bottlenose dolphin. A random sample of 50 adult bottlenose dolphins have a mean length of 12.04 feet with and I left off the word sample, so put sample there. That should be sample, standard deviation of 1.03 feet. Find and interpret a 90% confidence interval for the mean length of all adult bottlenose dolphins. Okay, so here we go. We know that the mean length is 12.04 and our sample standard deviation is 1.03 and we're looking at a sample size of 50 and we're going to do a 90% confidence interval. So here we go. Our formula. So we're going to take 12.04. Since our mean is 2 decimals, we're going to also round this one to 2 decimals. Plus or minus Now, if we're doing 50, and I should have said this when I wrote it, then our DF would have to be on row 49, okay? So, we're going to pull our chart up. So, when we are in row 49, and we're looking at 90%, we know that that's going to be the second number, because 80 is the first number, 90 is the second number. So we're looking at 1.677. Okay. 1.677 times 1.03 divided by the square root of 50. So 1.03 divided by the square root of 50 would give 0.145663,997 that we're going to multiply 1.677 and that would give us a margin of error of 0.244278,523 that we're going to add and subtract from 12.04. So when you subtract that from 12.04 and we're doing 2 decimals, you should get 11.795. I'm going to write that down so y'all can see. That's going to be 11.80. Make sure that 5 makes 9 go up to 80. To 12.04 plus 0.24278523. And that would give 12.28. So your confidence interval, and this is going to be in length. So this is feet. So we have 11.80 feet to 12.28 feet. And this will conclude 8.3. Next, I will give you some more in-depth word problems, and that will be on the next handout that will be in Canvas.